5.2, trig ratios. In a right triangle, one of the angles measures 90 degrees, and the remaining two angles are acute, which means less than 90 degrees, and complementary, which means that they add up to 90 degrees. The longest side of a right triangle is known as the hypotenuse and is opposite the right angle. The other two sides are called legs. The leg that is a side of an acute angle is called the side adjacent to the acute angle. The other leg is the side opposite the angle. So, if we are looking at this angle A, this would be the opposite side, and this is the adjacent side, and this is the hypotenuse. Angle A and angle C add up to 90 degrees because they are complementary. The ratios of the sides of the right triangles can be used to define the trigonometric ratios. Our mnemonic for remembering these is SOHCAHTOA. You should have learned this in physics. SOHCAHTOA. So the sine of an angle is the opposite side over the hypotenuse. This is the SO part of SOHCAHTOA. The cosine of an angle is the adjacent side over the hypotenuse. That is the CA part of SOHCAHTOA. And the tangent of an angle is the opposite side over the adjacent side. That's the TOA part of SOHCAHTOA. All right, so find the values of sine, cosine, and tangent for angle B. Here, so if the sine of angle B is going to be the opposite over the hypotenuse. Go ahead and write SOHCAHTOA up there so we remember. It's going to be the opposite over the hypotenuse. The opposite side is 18, and the hypotenuse is 33, and that's going to reduce to 6 over 11. The cosine of angle B is going to be the adjacent over the hypotenuse. But oh no, we don't know what this adjacent side is. We're going to have to use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse of a right triangle. So we'll make 18 be our a. We're trying to solve for b, and 33 is our c. That should be squared. So 18 squared is 324. 33 squared is 1089. So subtract 324 from both sides. We get that b squared equals 765. And b is going to be the square root of 765. I do not think that's a perfect square. It is not a perfect square. So we can leave it like this. We do want to simplify that. So we can simplify a perfect square by making a factor tree. This is going to factor, divides by 5, and 153. 153 divides by 3 and 51. 51 divides into 3 and, what, 17? 17. So anything that has a pair of factors can come out. So the 3 can come out. The 5 and the 17 stay in, and 5 times 17 is 85. So we get 3 square root of 85 as our adjacent side here. So cosine of angle B is going to be 3 square root of 85 over 33, or just square root of 85 over 11. Please leave it in terms of a square root. Do not make it a decimal. And then tangent of B is going to be opposite over adjacent, which is going to be 18 over 3 square root of 85, which would be 6 over the square root of 85. It's bad to have a square root in the denominator, so what we want to do is rationalize that denominator by multiplying both sides by the square root of 85, the numerator and the denominator by the square root of 85, and get 6 square root 85 over 85. As light passes from one substance, such as air, to another substance, such as glass, the light is bent. The relationship between the angle of incidence theta I and the angle of refraction theta R is given by Snell's law, which says that sine theta I over sine theta R is equal to n, where sine theta represents the trigonometric ratio and n is a constant called the index of refraction. Suppose a ray of light passes from air with an angle of incidence of 50 degrees to glass with an angle of refraction of 32 degrees and 16 minutes. Find the index of refraction of the glass. So we want to solve for n here. So that's going to be equal to sine of the angle of incidence is 50 over sine the angle of refraction is 32 degrees and 16 minutes. We can't put 16 minutes into our calculator, so we're going to convert this to decimal degrees. All right, 32 degrees plus 16 over 60. Which is going to be 0.267. And then we would need to put that into our calculator. That's not something that we can do on our own. So we do sine 50 divided by sine of 32.267. And that gives us 1.435. As our n, our index of refraction. In addition to the trigonometric ratios sine, cosine, and tangent, there are 3 other trigonometric ratios called cosecant, secant, and cotangent. Cosecant is the reciprocal 1 over the sine. So if sine is opposite over hypotenuse, cosecant is the hypotenuse over the opposite side. It's the reciprocal. You switch the numerator and denominator. Secant is 1 over cosine, which is going to be the hypotenuse over the adjacent side. And cotangent is going to be 1 over tangent, which is going to be the adjacent over the opposite. Note that cosecant is 1 over sine and secant is 1 over cosine. You think it should be the other way around, but it's not. Remember that. If cosecant theta equals 3/4, find secant theta. Or cosine theta equals 3/4. So secant theta equals 1 over cosine theta. So if cosine theta is 3/4, then secant theta is 1 over 3/4, which is the reciprocal, which is 4/3. If cosecant theta is 1.345, find sine theta. So cosecant theta is 1 over sine theta, which is 1.345. If we solve for sine theta, we multiply both sides by sine theta, we get that 1 equals 1.345 sine theta, and we divide by 1.345. We get that sine theta is equal to 1 over 1.345. And we can do that on a calculator. And that's 0.74. Find the values of the 6 trigonometric ratios for angle P. So angle P is here. In order to find these 6 trig ratios, we're going to need all 3 sides. So we're going to use Pythagorean theorem to find this hypotenuse. So 10 squared plus 7 squared equals c squared. And so that's going to be 100 plus 49 equals c squared, which means that this side is the square root of 149. 149 is not a perfect square, and I don't think it factors in any way. We're going to leave it as the square root of 149. So the sine of angle P is going to be the opposite side over the hypotenuse, which is going to be 7 over the square root of 149. And we will rationalize that denominator by multiplying by the square root of 149 over the square root of 149. Get 7 square root 149 over 149. Cosine of P is going to be the adjacent over the hypotenuse, which is going to be 10 over the square root of 149, which rationalizes to 10 square root 149 over 149. Tangent of P is going to be nice and simple. That's going to be our opposite over our adjacent, which is just 7 over 10. Secant P is 1 over cosine P. If our cosine P was 10 over the square root of 149, this is going to be the square root of 149 over 10. When you're taking the reciprocal, take the first one, not the rationalized version, because then when you take the reciprocal, you end up with the radical in the denominator again, and then you have to rationalize it again, and then you have to simplify again, and it gets you the exact same answer, but takes like 3 more steps. So, save time, work smarter, not harder, and use the original form, and just take the reciprocal of that. Cosecant P is going to be 1 over sine P. Sine p was 7 over the square root of 149, so this is going to be the square root of 149 over 7. And then cotangent p is 1 over tangent p. That was 7/10, so this is going to be 10 over 7. And hey, that's trig ratios. Not too bad so far. Tune in next time for the unit circle.